Hey there, 8th grade. In this video, we're going to be graphing absolute value functions. An absolute value function is written as f of x equals the absolute value of x. That's the basic absolute value function that we have. So basically, it's any function that has the x variable inside the absolute value bars. So what we're going to do is we're going to graph this function here using a table of values so we can see and remind ourselves what the basic shape of an absolute value function is. So if I plug each of these x values in for x for this function, the absolute value of -3 gives me 3 for my y value. The absolute value of -2 is +2. Absolute value of -1 is +1. The absolute value of 0 is 0. And then the absolute value of all of your positive numbers are just themselves, 1, 2, and 3. So the graph of an absolute value function is going to look like this. We have -3, 3 here, -2, 2, -1, 1, 0, 0, and then 1, 1, 2, 2, 3, 3. So it forms a V shape. And if you remember, we talked a little bit about these last year. Absolute value functions form V shapes. The domain of this graph would be all reals. And then the range of this graph would be all of the y values that are positive, so all of the y values that are greater than or equal to 0. Again, the graph looks like a V, and then we have a special point on this graph. In this case, it's a minimum point, or what we call the turning point, going from decreasing to increasing, and that is called the vertex of the graph. So to graph an absolute value function, we're going to start by finding the x value of that vertex, because the vertex is not always at the origin 0, 0. And so to find the x value of the vertex, we're going to set the expression from the inside of the absolute value bars equal to 0 and solve for x. Once we have the vertex, then we're going to use a table of values, using the vertex as the middle point in our table, and then we're going to complete the table by plugging in x values into our function, and then finally graph. So let's look at number 1 and see how this process works. We have f of x equals the absolute value of x minus 4. So my first step is to figure out what is the x value of my vertex. And again, I find that by taking the inside expression and setting it equal to 0. And if I solve this inside expression for x, I get x equals +4. So this is the x value of my vertex, so that's going to be the middle x value in my table. From there, I'm going to fill in the rest of my x column in my table, and I'm going to do that by just numbering 2, 3, okay, above my middle part, and then 5, 6 below. So I'm using x values of 2, 3, 4, 5, 6, again based on what this vertex value came out to be. When I plug each of these values into this function, you can use your calculators if you need to. You really shouldn't have to for a problem like this, but just a reminder on your graphing calculator, if you go to your scratch pad, you can find absolute value bars by clicking on this little button next to your 9, and then it's going to be this symbol right here. So if we do the absolute value of 2 minus 4, the first x value in our table, we get +2. Again, 2 minus 4 is -2. The absolute value of -2 is +2. Then we do the absolute value of 3 minus 4 to get +1. The absolute value of 4 minus 4 is 0. And then we have absolute value of 5 minus 4, which is again 1, and then absolute value of 6 minus 4, which is 2. So the y values of our table go 2, 1, 0, 1, 2 when we plug in these x values. Okay, so we're going to plot these points, 2, 2, 3, 1, 4, 0, 5, 1, and 6, 2. So we get the V shape of our graph, and it looks like this. The domain of this graph, well, the domain is going to be all reals, and the range of this graph, we've graphed all of the y values that are greater than or equal to 0. Okay, number 2, we're going to start out again with the expression inside our absolute value bars, 3x plus 2. We set that equal to 0 to find our vertex. So 3x is equal to negative 2, so our x value of our vertex is at negative 2/3. So that's the number that's going to go here in the middle of our table. Now, just because our x value of our vertex is a fraction does not mean that I need to make the rest of these x values fractions. I can still pick nice numbers to plug in. So I can pick negative 2 and negative 3, okay, for my two x values smaller than negative 2/3. And I can pick 0 and 1, or I could pick 1 and 2 for values larger. So now I'm going to plug each of these values into my absolute value function, 3x plus 2. So we have the absolute value of 3 times, I'll start with my negative 3, 3 times negative 3 plus 2, and that gives me 7. And then we have the absolute value of 3 times negative 2 plus 2. That gives me 4. The absolute value of 3 times negative 2/3 plus 2 gives me 0. Absolute value of 3 times 1 plus 2 gives me 5. And then the absolute value of 3 times 2 plus 2 gives me 8. So I have points at negative 3, 7, negative 2, 4, negative 2/3, 0 is my vertex, so that's going to be about right here, 1, 5, and then 2, 8. Okay, so just be really careful with how you connect your points here. It's still a V shape, and that shape looks like this. The domain of this graph, that's still going to be in all reals, and the range of this graph is going to be still all y values greater than or equal to 0. Okay, number 3, we have f of x equals negative the absolute value of x plus 1. So I'm going to start this again by finding the x value of my vertex. Remember, we're only taking what's inside the absolute value bars. So the inside is x plus 1. That's going to give me the x value of my vertex if I set that equal to 0. So my x coordinate of my vertex is negative 1. That's the middle value in my table. So then I'm going to pick other x values, negative 3, negative 2, 0, and positive 1 based on that. When I plug these values in, remember there's a negative sign in front of these absolute value bars. So what that means is every y value I get is going to become a negative because of this negative sign here. Okay, so we're going to start out by plugging in negative 3. So we have a negative on the outside of the absolute value bars. And then we're starting out negative 3 plus 1 on the inside. The absolute negative 3 plus 1 is negative 2. The absolute value of negative 2 is positive 2. But again, this negative sign on the outside is going to give us a negative 2 for our y value. And then we're plugging in negative 2, negative 1, 0, and 1. Remember, on your calculator you can always scroll up and hit Control-C to copy paste what you had previously put in. And so then I can Control-V to paste what was above here, and now I can just change this negative 3 to a negative 2, and I find out I get negative 1. Then I can change this to a negative 1, and I see I get 0. Then I can plug in my 0. I get negative 1 again, and then finally my positive 1 to get negative 2. So our table, negative 2, negative 1, 0, 1, and 2 for our y values. Okay, so we're going to plot these now, negative 3, negative 2, negative 2, negative 1, negative 1, 0, 0, negative 1, and 1, negative 2. So notice this graph is opening downwards, and the reason it's opening downwards is because of that negative sign in front of the absolute value bars. So the domain, as you might have guessed by now, all of these domains for just the absolute value graphs will be all reals. The range of this will be all the y values that are less than or equal to 0. Okay, number 4. So we're going to find the vertex. Again, we take just on what's on the inside of the absolute value bars. So I'm ignoring the minus 4 on the outside for a moment. So I have 1/2 x is equal to negative 1. So that means x has to be equal to negative 2. Multiply both sides by 2. So that's going to give us the middle value of our table. So I'll choose negative 4, negative 3, negative 1, and 0. When I fill in this table, go to my calculator, and so we're doing 1/2 times x, so we're going to start with 1/2 times negative 4 plus 1, and then on the outside of the absolute value bars we're doing our minus 4. So when I plug in negative 4 to my table, I get negative 3 for my y value. Okay. What I want you to do now is pause the video, and I want you to fill in the rest of this table, and then once you have this filled in, click play to check to see if you got that correct. Okay, so if you got those values correct, again, negative 3, negative 3.5, negative 4, negative 3.5, and negative 3 is what you should have. Okay. By the way, make sure you are able to also find these y values if you don't have your graphing calculator with you. There may be times in the future that I will restrict the use of your graphing calculators if I feel like you can't do this without one, so be sure you know your order of operations and how you can plug into your absolute value expressions and get these y values. Again, you want to use your calculators as a tool, not as a crutch. So negative 4, negative 3, negative 3, negative 3.5, negative 2, negative 4, negative 1, negative 3.5, and 0, negative 3. So your points are going to look like this, and then your graph is going to do this. Okay, the domain of this graph will be all reals. The range, this time you have a vertex at negative 2, negative 4. So all of your y values are greater than or equal to negative 4. Okay, they're all above negative 4, that minimum value. Okay, the last two examples are piecewise functions, which we talked about in the last video. So I'm going to start out number 5 with the top piece here, which we should know how to graph, hopefully, at this point. So we're going to start just with a little table that I'm going to make myself here with our boundary point of 4. If I plug a 4 into this top portion, I have negative 2 times 4 plus 1, which is negative 8 plus 1, which is negative 7. So I'm going to put a point at 4, negative 7 first, and it will be an open circle at 4, negative 7. And then we're graphing all x values to the left of 4, all those smaller than 4. So this is negative 2x plus 1, so the slope is negative 2. So I'm going to go up 2 and left 1 a few times to get the top piece of this function. Okay, the bottom piece, this is an absolute value function, but it's only for x values greater than or equal to 4. So I'm actually going to use this table here that I have already set for you, and my boundary point is going to be the first point that I plug in for x, since that's the smallest x value that I can have, and all of the other x values have to be larger than 4 based on that domain. So then I can plug in a 5, 6, 7, and 8. and then just plug these values into this bottom piece. So the absolute value of 4 minus 3 is 1. The absolute value of 5 minus 3 is 2, and then 3, and then 4, and then 5. So I'm going to use a solid dot for this first point because of this equal to bar. So 4, 1, and then 5, 2, 6, 3, 7, 4, and then 8, 5. So it is absolute value here, but because we've restricted the domain to just all the values that are greater than or equal to 4, we don't actually get the full V shape, we just get the right half of our V. Okay, so we get just a array, just like we do for a regular piecewise function for a line. The domain of this graph, the domain is going to be all reals. We've touched every single x value. The range, our minimum point is 4, -7, and we're not including -7 because of that open circle, so it's y is greater than -7 for our range. Okay, number 6, I'm going to do the top piece for you, and then I'm going to have you try the other two on your own. So the top piece here, again, we have an absolute value of 2x and then subtract 4. So I'm going to start with my boundary point in this table down here. I'm going to start at -3. And it's all of the values that are less than or equal to -3, so I'm going to go downwards here, -4, -5, -6, and -7. If I plug these into my top piece, 2 times -3 is -6, the absolute value of -6 is +6, and 6 minus 4 is 2. 2 times -4 is -8, its absolute value is +8, 8 minus 4 is 4, and then I can similarly go down the list. I'm going to get a +6, a +8, and then a +10 for my table. So I'm going to start out at -3, 2 using a solid dot, and then I'll graph -4, 4, -5, 6, -6, 8, and -7, 10. So this is my top piece for this piecewise function. I'm now going to pause the video and have you try the middle and the last piece, and then click play once you have it graphed. Okay, so this is what the rest of your function should look like. Our middle piece is just a horizontal line segment. We're on y equals -5, but we're between the points -3 and 2, and those are open circles. And then our last piece, starting at the point 2, 0, it's a solid dot, and we've graphed everything greater than 2, so everything to the right, and that just ends up being a line with a slope of 1. So the domain of this piecewise function, we've hit every single x value, so the domain is all reals. The range, we learned from the last time you were in class that we can write the range by saying that it's all y values that are either -5, or, so we use a union symbol, all y values that are greater than or equal to 0. So we're not including any of the negatives besides -5, but then we are including all y values greater than or equal to 0. Okay, any questions you had over this video, make sure you ask those the next time you're in class. Until then, folks, have a nice day. You're all wonderful people. Take care.